I would like to thank the Society of Flavor Chemists for the opportunity of presenting my research in this meeting. My name is Angelica, and I am a graduate student in the Food Science and Technology Department at Oregon State University. Last year, I was awarded with the William F. Jaggard Memorial Scholarship, and I'm really happy to share with you some of the results of the work I did with Dr. Elizabeth Tomasino, an associate professor at Oregon State. As you will see today, a big part of my research is on finding the causes of tropical fruit aroma in white wines. I hope we all can learn something today, so let's get started. I will be happy to answer any questions in the end of my presentation if you have them. If you regularly drink wine, you're probably familiar with the steps of wine tasting. The second step is when we analyze the orthonasal aroma of the wine, and we usually do that before drinking the wine. If we think about it, this is actually something good, because if you don't like the aroma of the wine, you have the option to not drink it. So we have to agree that the aroma of wine is one of its most important quality attributes. Every wine is unique. When we smell a wine, we think about the different aroma attributes that are applicable to that wine. These aromas are directly related to the volatile composition of the wine. One class of aromas we can smell, especially in white wines, is the tropical fruit aroma. Tropical fruit is a generic term, and it usually stands for aromas of passion fruit, guava, grapefruit, mango, and pineapple. There is substantial work in the literature relating tropical fruit aroma in wine to volatile thiols. This aroma family have their origins in the grape berries, thus they are considered varietal aromas. These four compounds, 3-MH, 3-MHA, 4-MMP, and benzylmercaptan, are impact aroma compounds, meaning that their presence can directly influence the aroma perception of wine. As you can see in this table, volatile thiols are found in the nanogram per liter range in wine, and they have very low perception thresholds. In wine, 3-MH, 3-MHA, and 4-MMP impart aromas of passion fruit, guava, grapefruit, box tree, and citrus. Benzylmercaptan, on the other hand, imparts aromas of smoke, struck, and flint. This aroma family is abundant in Sauvignon Blanc wines, but more recent studies have found concentrations of free volatile thiols in other white wine varieties, such as Chardonnay, Gewürztraminer, Riesling, Muscat, and so on. In 2021, we are completing 40 years of research on volatile thiols in wine. Wine thiols are a very broad and complex topic, and there are all sorts of research in this area. Consumers enjoy the very pleasant tropical fruit aromas imparted by volatile thiols. Therefore, it becomes necessary to understand exactly what are the causes of this aroma in white wines. And that's exactly where my research takes place. Like I said before, there are a large number of published work relating volatile thiols to tropical fruit aromas in wine. While this fact remains true, and volatile thiols are strongly correlated to tropical fruit aromas, it is extremely important to investigate how the several aroma families present in wine behave in wine media. This is done to assess any possible interactions that may cause specific aroma perceptions. The work done by King and his colleagues in 2011 showed for the first time evidence that thiols by themselves may not contribute to tropical fruit aroma. In this work, several combinations and concentrations of volatile thiols esters, and methoxypyrazines were added to a wine model, and the samples were subjected to sensory descriptive analysis. This figure is a principal component analysis plot, and it shows the results obtained in sensory analysis. The open circles are the ester plus thiol treatments. If we look at the first quadrant, we can see that the two ester plus thiol treatments are in the direction of the tropical fruit aroma vector. This study showed evidence that thiols may not be the only cause to tropical fruit aroma in wine, but more work is necessary to prove this fact. Wine quality is subject to high variations from year to year. Winemakers are always trying to achieve consistency, as this is a key factor to wine quality and consumer liking and purchase. Therefore, understanding the causes of aroma or any other attribute of wine is crucial to achieve wine quality. Once we understand the causes of a specific quality attribute and how that can be achieved, we can adapt viticultural and/or winemaking conditions and finally achieve consistency every year, despite any vintage challenges. So in this work, we wanted to find out the possible causes for tropical fruit aroma in wine. We were specifically interested in investigating the effect of fermentation esters and volatile thiols. But to answer this big question, we had to elaborate different experiments that answers the three following questions. Do volatile thiols impart tropical fruit aroma in white wine by themselves? Do fermentation esters and volatile thiols in combination impart tropical fruit aromas? What about fermentation esters by themselves? And finally, does tropical fruit aroma perception and intensity change with varying concentrations of esters and/or volatile thiols? So to do this work, we followed this preparation procedure for the wine we used as our model. We made a neutral Pinot Gris wine and de-aromatized it using Liquorlut N. After that, we added a pool of aromas that are formed during wine fermentation. This was the wine base model used for all treatments and the control. The wine was bottled, and the treatment aromas were added to the bottles. These are all the treatments, and they were assessed over two different studies. In study 1, we wanted to evaluate if there is any difference in sensory perception of a wine spiked with only volatile thiols versus wines spiked with thiols and increasing concentrations of esters. In study 2, we investigated how the different concentrations and combinations of thiols and/or esters impacted sensory perception and intensity of the aroma attributes. These are the concentrations of thiols we used in study 1 and study 2. I did not include the concentrations of esters because it is a long list of more or less 20 ethyl and acetate esters that would not fit in this slide. However, if you have any questions regarding the ester compounds used and their respective concentrations, I will be happy to answer them in the end of this presentation. So, all wine treatments from study 1 and study 2 were subjected to sensory analysis. The first sensory method was check all that apply, or CATA. A total of 46 untrained white wine consumers were asked to smell the samples and check 2 to 5 descriptors off of a list containing 25 aroma descriptors. The second method was sensory descriptive analysis, where 13 trained panelists assessed the intensity of the 8 most commonly used aroma descriptors listed in the CATA study. These two figures are called correspondence analysis map, and they show the results of the CATA panel. On the left side is the result of study 1. The first two factors explained 87% of the total variance. Factor 1 separated the control and thiol treatments from all thiols plus ester treatments, indicating that the aroma of the thiol treatment and thiol plus ester treatments were very different. Study 1 showed us that thiol by themselves caused grassy and earthy aromas, and not tropical fruit aromas. Tropical fruit aromas were associated with the thiol plus ester treatments. On the right side is the result of study 2. The first two factors explained 66% of the total variance. Again, we could see a similar result to what we saw in study 1. Factor 1 separated the control and thiol treatments from all thiol plus ester treatments and esters only treatments. The ester combinations, or treatment 2 and treatment 3, were also associated with tropical fruit aromas, which was a very interesting result. Study 2 showed us that thiol plus esters and esters only are possible causes of tropical fruit aroma in white wine. Now we are going to see the results of sensory descriptive analysis. These two figures are the discriminant analysis plots for study 1. On the left side, we see the treatments, and on the right side, we see the descriptors associated with each treatment. To interpret these figures, we should overlay one on top of the other. 88% of the total variance was explained by the first two factors. The results obtained by the trained panel were very similar to the results obtained with consumers in the CATA panel. The control and the thiol treatments were separated from the ester plus thiol treatments by factor 1. The control and the thiol treatments were again associated with earthy and grassy aromas, and the tropical fruit aromas were associated with ester plus thiol treatments. These two figures are the discriminant analysis plots for study 2. 77.25% of the total variance was explained by the first two factors. Treatments 4, 5, and 6 are the low, medium, and high thiol concentrations, and we can clearly see that they are associated again with earthy and grassy aromas. Again, the tropical fruit aroma descriptors were related to the thiol plus ester concentrations and esters only. Now, we are going to see some bar charts in order to understand the trends in intensity for some selected descriptors used in the sensory descriptive analysis panels. Treatment 4 in study 1, which is the median ester plus thiol combination, and the treatment 3 and treatment 7, that respectively are the median ester and low ester plus low thiol combination, presented higher intensities for passion fruit aroma. The opposite trend was observed in treatment 2 in study 1, and the treatments 4, 5, and 6 in study 2, which are the low thiol combinations. Moving on, we could see that the intensity of guava decreased with increasing concentrations of thiols when we look at treatments 4, 5, and 6 in study 2. On the other hand, treatments 9 and 12, which respectively are the low esters plus high thiols and median esters plus high thiols, presented the highest intensities for the guava descriptor. Now let's look at the grass descriptors. The highest intensities of grass aroma were observed in the treatments containing only thiols, while all the other treatment combinations did not impart such aroma, with the exception of the control in study 2. Finally, let's look at the earthy descriptor. A similar trend was observed for the earthy aroma, where only the thiol treatments presented positive intensities. An interesting result in study 2 is that the higher the concentration of thiols, the higher the earthy aroma intensity. In conclusion, the results of this study showed us that volatile thiols by themselves contribute very weakly to tropical fruit aroma in white wine in the combinations and concentrations evaluated in this study. Thiols rather contribute to grassy and earthy aromas. One of the causes of tropical fruit aroma occurred due to the combination of volatile thiols and esters. Another cause is the fermentation esters by themselves when present in medium to high concentrations in white wine. This was a very interesting result. The results give us enough evidence that to achieve tropical fruit aroma in white wine, it is not only important to include procedures that will increase the concentrations of volatile thiols during winemaking. It is also extremely important to increase fermentation esters in wine, and winemakers should know that. I would like to thank the American Vineyard Foundation for funding part of this research project. I would also like to thank Dr. Elizabeth Tomasino for the support and guidance in this study, and Aubrey Dubois for helping me recruiting panelists. Lastly, I would like to thank all the undergraduate students that helped me during sensory analysis. Thank you very much for your attention, and I'm happy to answer any questions.